Welcome to the beginning of the end. Tonight, we do not look back to where we came from, but forward to where we are all going. We begin a journey not through space, but through time, a voyage to the very last chapter of our universe's story. This is not a tale of fear, but of profound peace. It is the story of the long goodbye, the gentle dimming, the final silence. Our journey is called the last light, and our first step begins in an era that is, in cosmic terms, just around the corner. The era when the stars begin to say their farewells. Picture our universe today. It is a vibrant, luminous tapestry. Galaxies spin. Stars are born in great nebulous clouds. They live, and they die in spectacular supernovae, scattering the elements of life across the void. It is a story of fire and rebirth. But this era of stellar fertility has an expiration date. The fuel for new stars, the vast clouds of hydrogen gas, is finite. Across trillions of years, galaxies will use up their reserves. Our story truly begins 100 trillion years from now. This number is not meant to overwhelm, but to lull. It is a time scale so vast it soothes the mind. In this distant future, the great stellar nurseries have grown dark. The last star has been born. The universe is no longer a place of birth. It is a place of long, slow aging. The first to leave us will be the most massive stars, the brilliant blue, short-lived giants. They will have vanished long before this era, in explosions that seeded the cosmos with heavy elements. Then, stars like our own sun will reach their end. They will swell into red giants, perhaps engulfing their inner planets, before shedding their outer layers and shrinking into Earth-sized embers, called white dwarfs. These white dwarfs will glow with a faint, residual heat for eons, but they are no longer true stars. They are cosmic coals, cooling in the dark. But the sky is not yet dark. Smaller, cooler, more frugal stars, the red dwarfs, will stubbornly cling to life. Stars like Proxima Centauri can burn for trillions of years. They will be the last bastions of starlight in their galaxies. Imagine our night sky, but with only a handful of faint, deep red pinpricks against an ever-deepening black. The familiar constellations are gone, their patterns dissolved by the relentless galactic dance over eons. For it is not just the stars that are changing. The galaxies themselves are aging. Our own Milky Way and its great neighbor, the Andromeda Galaxy, are already on a collision course. In about 4 to 5 billion years, a mere blink in the timescale of this story, they will begin a slow, graceful, billion-year dance of merger. They will not crash. They will embrace, their stars weaving through each other's spaces, their structures blurring. The beautiful spiral arms will be stirred into a new, formless shape, a giant elliptical galaxy. Some call it Milkdromeda. By the time our era of degenerate stars is in full swing, this merger is a distant memory. All galaxies in our local group have likely coalesced into one vast, diffuse island of stars adrift in an incomprehensibly vast and growing emptiness. The expansion of the universe has carried all other galaxies beyond our cosmic horizon. Their light can no longer reach us. To any observer in Milkdromeda, the universe outside their own galaxy appears utterly, perfectly, and forever black. The concept of a universe full of galaxies has faded into legend. This is the stage we set, a single, aging galaxy, adrift in an infinite black sea. Its remaining stars, the long-lived red dwarfs and the cooling white dwarfs, are the last candles in a cavern that grows colder and quieter with each passing eon. As you listen, let go of the need for a bright, busy cosmos. Embrace this slower, quieter reality. There's a deep peace in this slowing down. The frantic era of creation is over. What remains is the long, gentle exhale. The universe is not dying yet, it is settling. It is finding a slower, more contemplative rhythm. In this rhythm, there's a strange beauty. The last red dwarfs burn with a patience we cannot fathom. The white dwarfs, diamonds the size of worlds, cool with a grace that defies time. The galaxy turns, silent and majestic, a great clock winding down with impossible slowness. This is not an end, but a transition. The age of fire is giving way to the age of embers. And in the deep, quiet glow of those embers, the next, even longer chapter of our universe's story will quietly begin. As the last red dwarfs finally exhaust their hydrogen fuel, a profound change sweeps through the galaxy. Their deaths are not violent like their massive cousins. There's no supernova. Instead, they simply dim. Their nuclear furnaces sputter and go quiet. They shed their outer layers, not in a blaze, but in a gentle whisper of gas, and contract into new white dwarfs. The era of fusion, the process that has powered the stars and lit the universe since nearly its beginning, is over. The last true star has winked out. What remains is a galaxy populated by the degenerate remnants of stars, white dwarfs, neutron stars, and the wandering, unseen brown dwarfs that never truly ignited. This is the era that gives our chapter its name, the degenerate era. Degenerate here does not mean immoral or fallen. It is a precise term from quantum physics. It refers to a state of matter so dense that its structure is upheld not by thermal pressure or nuclear fires, but by the fundamental quantum mechanical law that forbids particles from occupying the same state, a force called degeneracy pressure. White dwarfs are supported by electron degeneracy pressure. Neutron stars by neutron degeneracy pressure. They are not alive, they are fossils, held in a permanent, unchanging configuration against the endless pull of gravity. These stellar corpses are the new landmarks of the cosmos. White dwarfs, composed mostly of carbon and oxygen, will slowly, over epochs longer than the current age of the universe, crystallize into giant diamond-like structures. Imagine a sphere the size of Earth, but with the mass of the Sun, its interior slowly solidifying into a perfect, cold lattice. They will emit no light of their own, only a faint, fading glow of residual heat. Their surface temperature will approach the background temperature of the universe itself. Yet, even in this darkening realm, there are fleeting moments of light. Occasionally, two brown dwarfs, failed stars too small to sustain fusion, will drift together over eons and collide. This rare event can briefly ignite a new, temporary star, a red dwarf that will shine for a few trillion more years before fading again. It is a last echo of the stellar era, a final spark in the deepening gloom. More dramatic are the encounters between white dwarfs. If two spiral slowly together, pulled by the emission of gravitational waves, they can merge. Depending on their masses, this merger can trigger a cataclysmic Type I supernova, a brilliant thermonuclear explosion that, for a few weeks, can outshine an entire galaxy of degenerate stars. In our future galaxy, such an event would be a staggering, isolated flare, a single, brilliant punctuation mark in a sentence that is otherwise growing faint. It would be the last firework in the cosmic display, a final reminder of the violent beauty that once was common. But these events are rare, separated by timescales that dwarf human history. For the most part, the galaxy is a place of profound stillness and gradual decay. The dynamical processes that once shaped it have slowed to a near halt. Stars are so far apart that close encounters are almost unheard of. The great dance has become a stately, imperceptible drift. This is the universe settling into its old age. The frantic energy of its youth is spent. What remains is a landscape of incredible stability, but also of inevitable decline. The law of entropy, the tendency of all ordered systems to move toward disorder, is asserting its quiet dominion. The universe is becoming a more uniform, more disordered, and colder place. And yet, for a being that could perceive it, this era would hold a majestic, somber beauty. A galaxy of frozen diamond stars, each a monument to a past age of light, drifting in a sea of perfect black. The chaotic, creative frenzy of the early universe has been replaced by an almost meditative calm. It is a universe that has run its active course and is now reflecting, cooling, and simplifying. As you imagine this scene, let the sounds in your mind match the vision. The faint pings and chimes of cooling white dwarfs are now even more sporadic. They are joined by an even deeper, more pervasive sound, the low-frequency thrum of gravitational waves. These are not the violent chirps from black hole mergers we detect today, but the steady, nearly monotone hum produced by the slow, inexorable orbits of binary white dwarfs and neutron stars spiraling toward their fate over hundreds of trillions of years. It is the sound of the galaxy's clockwork, winding down with infinite patience. We are witnessing the long goodbye of light itself. But even as the last echoes of starlight fade, the universe is preparing for the next, even more exotic act in its long play. The degenerate remnants are not the final state. They are merely the next step on the path to an even deeper silence. As we approach the end of this first chapter, we must confront a profound shift not just in the state of the cosmos, but in the very nature of time and narrative. We are leaving behind a universe as a story of events, of births, explosions, collisions, and creations. We are entering a universe where the story is one of absence, of gradual dissolution, of processes so slow they become a form of permanence. The degenerate era will last for timescales that defy metaphor. We speak of quintillions of years. In this span, even the most stable structures begin to unravel through quantum mechanical processes. The solidity of matter itself becomes a temporary condition. Consider the fate of the galaxy itself. Over these unimaginable eons, The gentle drag of gravitational wave emission from orbiting stellar remnants will cause their orbits to decay. Some will merge in silent, dark events, but more significantly, a slower, subtler process will take hold: gravitational encounters. Even in the vast emptiness of the galaxy, the occasional, incredibly rare close pass between two degenerate objects, white dwarfs, neutron stars, brown dwarfs, will occur. These encounters act like a cosmic game of billiards on a table the size of a galaxy, played over quintillions of years. Through these slow, statistical exchanges of energy, some objects will gain enough velocity to be ejected from the galaxy entirely, cast adrift into the intergalactic void. Others will lose energy and sink closer to the galactic center. This process, known as gravitational evaporation or relaxation, will take place over timescales so long that the galaxy will gradually, imperceptibly dissolve. Its outer regions will bleed stars into the darkness. Its core may contract slightly. The grand, unified island of stars that was Mildromeda will begin to dissipate, like a sandcastle succumbing not to a wave, but to the patient, individual removal of 1 grain of sand per century. But long before the galaxy fully evaporates, something else will happen to the matter within it. This is where our story touches the truly fundamental. Protons, the building blocks of atomic nuclei, which have been stable for all of recorded history and for the 13.8 billion years of the universe's life, may not be stable forever. Many grand unified theories of particle physics predict a process called proton decay. A proton, left alone for long enough, could spontaneously transform into lighter particles, a positron and neutral pions, which would then decay into photons and neutrinos. The predicted half-life for protons is staggering, on the order of 10 to the power of 34 years or more. If protons do decay, then during the degenerate era, the very bedrock of ordinary matter will begin to crumble. White dwarfs and neutron stars, which are made of protons and neutrons, which themselves contain protons, will not last forever. They will slowly, ever so slowly, evaporate into radiation. A white dwarf would not simply vanish, it would fade, its mass converting into a faint, diffuse glow of energy over a timescale that makes the current age of the universe seem like a single heartbeat. Whether proton decay is a true law of nature remains unproven, but its possibility forces us to confront the ultimate transience of all structures. In the degenerate era, we face two possible destinies for matter. Either it remains locked forever in degenerate stellar corpses, or it undergoes a slow, majestic radioactive decay into pure light. Both paths lead to darkness. They just take different, unimaginably long roads to get there. As this first era draws to a close, the universe is a profoundly different place. The sky is black, save for the rare, faint glimmer of a colliding brown dwarf or the last flash of a merging white dwarf supernova. The dominant sounds are the deep hum of gravitational waves and the occasional, almost statistical, pop of a proton decaying somewhere in the vastness of a dark star. The temperature of the universe continues to drop, approaching ever closer to absolute zero, driven by the relentless expansion of space itself. This is not a violent end. It is a fading, a quietus. The universe is becoming a museum of its former glory, with exhibits that themselves are slowly turning to dust. There's a deep, melancholic peace in this image. All struggle has ceased. All conflict is over. The universe is at rest. But rest is not the end. Even in this deepest quiet, change persists. And the next change will be ushered in by the last objects with enough gravity to truly bend space-time, the black holes. Their era is waiting in the wings, a chapter of even deeper darkness and more profound transformation. But that is a story for our next journey. For now, as this chapter ends, let the image of the last white dwarfs, cold, crystalline, and dark, linger in your mind. They are the tombstones of the stellar age. Their long, slow fade is the universe's first, soft whisper of its final vow of silence. It is a goodbye stretched across quintillions of years, so gradual it feels like forever. And in a way, for anything that remains, it is. We have passed through the era where the last stars faded, leaving a galaxy of dark, degenerate remnants. Now we journey further into the future, to a time where even those remnants are no longer what they seem. We enter an epoch measured not in quintillions, but in googolls of years, a one followed by 100 zeros. This is the era of the long decay, where the universe achieves a state of near-perfect stillness, and the very nature of matter undergoes a silent, inevitable transformation. Our story hinges on one of the most stable nuclei in the universe, Iron 56. In the hearts of massive stars, nuclear fusion is a ladder that climbs toward iron. Fusion up to iron releases energy. Fusion beyond iron consumes it. Thus, iron is the ash of stellar furnaces, the end of the line for fusion. In our current universe, iron is common but mixed with other elements. In the unfathomable future of the long decay, iron may become the only element. How could this be? Through a quantum mechanical process so slow it makes proton decay seem rapid, quantum tunneling. In ordinary conditions, other atomic nuclei are stable. But given enough time, truly, almost infinite time, even stable nuclei have a tiny, non-zero probability of tunneling into a lower energy state. The lowest energy state for baryonic matter is believed to be isotopes of iron, like iron 56 or nickel 62. Over timescales so vast they are essentially philosophical, around 10-carat 1500 years. Quantum tunneling could cause all matter in the universe to gradually, atom by atom, transmute into iron. Imagine a universe where every mountain, every planet, every white dwarf and neutron star, should they have avoided proton decay, has been converted into cold, solid iron, not a lump of ore, but a perfect, crystalline sphere of pure ferium, the ultimate, final form of matter. These are the iron stars, theoretical objects that are not stars at all, but the universe's final, frozen monuments to itself. They would be black, smooth, and perfectly cold, reflecting no light, because there is no light left to reflect. They would be the sole occupants of a space so empty that the nearest such sphere might be farther from its neighbor than our current galaxy is from its nearest neighbor today. This is the zenith of cosmic loneliness. The expansion of the universe has continued relentlessly. Every object not gravitationally bound has been carried away by the stretching of space to distances that make them forever invisible and unreachable. Even the once great galaxy has evaporated through the slow processes of relaxation and ejection. What remains are isolated iron stars, or perhaps small, bound clusters of them, each an island universe in truth, separated by voids so immense that light could cross them only in timescales longer than the current age of the universe many times over. There are no events to witness, no changes to observe. The cosmos is a static, black, three-dimensional canvas with a few perfectly dark, perfectly cold specks of iron scattered across it. Time, in any meaningful sense, begins to lose its meaning. With no processes to mark its passage, no orbits, no decays, no fusion, no chemical reactions, time becomes a coordinate without an arrow. It is a dimension, like space, through which nothing moves. For an observer on, or more accurately, in, for they would be frozen solid, an iron star, the universe would appear utterly and permanently the same from one moment to the next, for gewgaws of years. As you begin to sink into this concept, let the soundscape guide you. That deep, periodic pulse, the last marker of any temporal rhythm, slows even further. The space between pulses stretches from minutes to hours, to years, to millennia in your perception. The foundational tone remains unchanging, the sound of maximum entropy, of a system that has reached equilibrium. There's no disorder left to increase toward. Disorder is total, and thus, in a paradoxical way, it feels like perfect order. This is not an era of death, but of completion. The universe has finished its work. It has taken all the chaotic energy of the Big Bang and processed it, through stars and galaxies, into a state of perfect, crystalline rest. All potential has been realized. All energy gradients have been leveled. It is the cosmic equivalent of a finished symphony, where the last note is faded and the hall is silent, the score complete. Yet, even here, at the theoretical limit of stability, there may be one last, subtle process at work, and it involves the most dominant force in this dark era, gravity. For while iron stars may be the final state of matter, they are not immune to the slow, relentless pull that bends space-time itself. Their existence sets the stage for the next, and perhaps most dramatic, caretakers of the late universe, black holes. But before they claim their dominion, the iron stars will keep their silent, cold vigil in the endless night, that I end this epic of iron and silence, the concept of observer becomes a paradox. To observe requires change, a photon to strike a retina, a neuron to fire, a thought to form. But here, change has been diluted to near non-existence by the vast ocean of time. Yet, let us indulge in a thought experiment. Imagine a consciousness somehow preserved within an iron star, a frozen sentience with perception stretched across gewgaws of years. What would it experience? Its universe would be a sense deprivation chamber of cosmic scale. No light, no sound, no heat or cold, for its body would be in perfect thermal equilibrium with the near absolute zero void. Its only sensory input might be gravity, the gentle, unmoving tidal pull of its own form, and the faint, unchanging whisper of gravity from the nearest iron star, trillions of light years away. This pull would not change, nor vary. It would be a constant, like the bass note of reality itself. Time for this being would not flow, it would congeal. With no events to segment eternity, the past, present, and future would merge into a single, permanent now. The memory of a stellar nursery, of a supernova, of a galaxy teeming with light, would be less like a recollection and more like a myth of a different reality, so distant it might as well be a dream. The being's own thoughts would slow, each cognitive process lasting millennia, until thought itself ceases to be a sequence and becomes a state, a single, eternal contemplation of the void. This is the ultimate meaning of entropy's victory. Entropy is not merely disorder. It is the loss of the ability to do work, to cause change, to process information. In the era of iron stars, the universe has reached maximum entropy. There are no hot spots to drive engines, no energy gradients to power storms or life or thought. Information in the physical sense still exists. The position of each iron atom is information, but it is frozen information. It cannot be read, processed, or changed. The universe has become a read-only memory, written once and fixed for eternity. Yet, within this absolute stillness, the laws of physics still whisper their final, subtle predictions. Two iron stars, if they are gravitationally bound in the last binary pair in existence, will still emit gravitational waves. Their orbit, already likely with a period of millions of years, will decay over timescales that make the long decay seem short. Eventually, they will merge, but this merger will be dark and silent. No brilliant explosion, for nuclear fusion is impossible in iron. The collision would be a slow, stately, cold accretion, two spheres of metal merging into one, releasing a final, barely detectable pulse of gravitational waves, the last ripple in space-time before the eternal calm. More intriguing is the fate of the iron stars themselves. Even in their perfect low-energy state, they are subject to the same quantum mechanical instability that may affect all matter, tunneling to a black hole. In quantum theory, there's a tiny, non-zero probability that any configuration of matter could spontaneously quantum tunnel into a different configuration, including that of a black hole. For an iron star, the probability is astronomically small, so small that the expected time for it to happen is far longer than the age of the universe, perhaps longer than the Google-year timescales we are discussing. But given true eternity, even events with probability zero for all practical purposes become certainties. Thus, given enough time so vast it has no meaning, every iron star could, in theory, vanish in an instant, replaced by a tiny quantum black hole. This would not be a violent collapse. It would be a quantum disappearance, a transition from one stable state to another without passing through the intermediate states. It is the universe editing itself out of existence, one perfect sphere at a time. But we are getting ahead of ourselves. For now, in the heart of the long decay, the iron stars persist. They are the universe's final, stoic sentinels. They represent the end of chemistry, the end of nuclear physics, the end of complexity. They are simplicity itself, cold, dense, and silent. This era teaches us a profound lesson about the nature of existence. Our universe of vibrant light and turbulent motion is a fleeting spark in the darkness of eternity. The default state of the cosmos is not fire, but ice. Not change, but stillness. Not story, but statue. Our current age is a magnificent but temporary deviation from this ultimate equilibrium. As you let this reality settle into your mind, feel the weight of that eternal tone in the soundscape. It is not oppressive, but serene. It is the sound of all struggle ended, all questions answered, all journeys completed. There is a deep, unspeakable peace in this absolute resolution. The universe is no longer becoming. It simply is. And in that state of pure being, the final actors wait patiently in the wings. For when even iron yields to quantum chance, or when the last gravitational orbit decays, the stage will be set for the true lords of the end times, black holes. Their era is one of both immense power and inevitable evaporation, a last flicker of activity before the final, eternal silence. But that story belongs to the next chapter of our journey to the end of time, that as we prepare to leave the era of iron stars, we must confront the most profound consequence of this endless equilibrium. The end of meaning, not in a philosophical, existential sense, but in a literal, physical one. Meaning in a universe arises from difference, hot versus cold, dense versus diffuse, past versus future. It arises from relationships and contrasts that allow for information, structure, and narrative. In the long decay, difference has been erased. The universe is homogeneous, isotropic, and in perfect thermodynamic equilibrium. It is a state of cosmic sameness. In such a state, the very concepts that define our reality dissolve. Distance loses meaning when there is nothing to travel between. No change in scenery to mark the journey. Time loses its arrow when there are no events to order into a sequence of before and after. History is not just forgotten, it becomes physically irretrievable. The light from past events has redshifted into undetectability. The matter that bore witness has transmuted into uniform iron, and the space-time fabric itself has stretched, diluting any fossil imprint of earlier eras to below of the quantum noise floor. The universe has no memory. This is the ultimate erasure. Not a violent deletion, but a gentle, overwhelming fade to gray. All the stories, the formation of the first atoms, the ignition of the first stars, the rise of life on a tiny blue planet, the dreams and wars and loves of countless beings, are not lost in the sense of being destroyed. They are lost in the sense that there is no substrate left upon which they are written. The universe has reformatted its hard drive, not with zeros, but with a single, unbroken value, iron at near absolute zero in maximum entropy. It is a peaceful apocalypse. There is no pain, no fear, no loss, because there is nothing left to feel it. It is the universe achieving a kind of nirvana, a release from a cycle of change and suffering that defines existence in its earlier, more vibrant phases. Yet, within this nirvana, the seeds of the next phase are subtly sown. For gravity, the weakest but most patient and far-reaching of forces, never sleeps. Even in a perfectly uniform universe, infinitesimal quantum fluctuations in the density of the iron fog exist, and over timescales that make the long decay seem like an introductory chapter, gravity can amplify these fluctuations. This is the process of gravitational instability, the same force that gathered the first galaxies, but operating now on a scale and slowness that is almost mystical. Given enough time, timescales so long they are often denoted as 101,026,101,026 years or more, these quantum fluctuations can, statistically, gather enough mass to form black holes directly from the diffuse matter and energy of the decayed universe. This is not the collapse of a star, but the slow, gravitational condensation of a near-perfect vacuum into a singularity. These would be primordial black holes of the late universe, born not from the fire of the Big Bang, but from the infinite patience of gravity in the darkness. But more immediately relevant are the black holes that formed in earlier eras, the stellar mass black holes from dead massive stars, and the supermassive black holes that once lurked in galactic hearts. Many of these would have evaporated via Hawking radiation by this point, if they were small, but the largest ones, with masses of thousands to billions of suns, have lifetimes that stretch far beyond the era of iron stars. They are the last structures standing, the final monuments to an age of gravity and light. These black holes, having consumed or been left alone by the dissipating galaxy, now drift in the void. They are no longer fed by accretion disks. There is nothing left to accrete. They are isolated, quiescent, and dark. They are perfect absorbers in a perfect darkness. Yet they are not inactive. According to Stephen Hawking's great insight, they glow with the faint thermal radiation, Hawking radiation, caused by quantum effects at their event horizons. For a massive black hole, this glow is unimaginably faint and cold, far below the temperature of the cosmic background. But as the universe cools further, this feeble emission will become, relatively, more significant. The black hole will be a slightly warmer speck in an even colder sea. And so, the stage is set for the next era. The age of iron and silence gives way, not with a bang, but with the slow, inevitable whisper of quantum mechanics and gravity. The black holes, these last bastions of extreme space-time curvature, inherit the universe. Their reign will be long, dramatic in its own subtle way, and will ultimately lead to the universe's final, fleeting burst of light before the true, eternal dark. But that is the next part of our journey. For now, as we leave the long decay, take with you the feeling of that infinite stillness. It is not emptiness, but fullness, a fullness of completion. There's a deep, resonant peace in knowing that all struggles, all chaos, all complexity eventually finds rest. The universe, in its old age, becomes simple, quiet, and whole. Let the sound of this era be your guide into sleep. That single, eternal tone is the sound of resolution. It is the universe's long, slow exhale after the frantic breath of creation. There's no more need to hold on. There's only the gentle, endless letting go. We have passed through the fading of light and the silence of iron. Now we enter an era where the universe is ruled not by fusion, not by chemistry, not by nuclear decay, but by gravity in its most absolute form. This is the black hole era. In this chapter, the last structures with any semblance of power and eventfulness preside over a cosmos that is otherwise cold, dark, and nearly dead. Their reign is long, quiet, and ends in a final, ironic burst of light. The era begins as the last degenerate stars, white dwarfs, neutron stars, and the hypothetical iron stars meet their fates. Some are ejected into the void. Others slowly spiral together and merge in dark, silent events. Many, if protons decay, will have sublimated into radiation over the eons. What remains are the objects immune to these forms of decay. Black holes. Black holes are not simply objects. They are regions of space-time from which nothing, not even light, can escape. They are defined only by their mass, spin, and charge, a simplicity summed up by John Wheeler's phrase, "Black holes have no hair." In this late epoch, they are the only things left that have a distinct identity, a localized gravitational presence in an otherwise uniform sea of near-nothingness. These black holes come in a range of sizes. There are the stellar mass black holes, the remnants of massive stars that died long before the degenerate era. There are the intermediate mass black holes, possibly formed from mergers or in dense ancient clusters. And there are the supermassive black holes, the monsters that once lurked at the centers of galaxies, now stripped of their stellar entourages, alone in the dark. The largest of these, may have masses billions of times that of our sun. For an unimaginably long time, these black holes will simply exist. They will drift through the expanding void, their immense gravity subtly influencing the paths of any stray particles or photons that pass by, but with no accretion disks, no infalling matter to create brilliant quasars or X-ray flares. They are dark kings on empty thrones. Yet, they are not completely inert. In 1974, Stephen Hawking made a revolutionary prediction using quantum mechanics near a black hole's event horizon. He determined that black holes should not be perfectly black. Due to quantum fluctuations, they emit a faint thermal radiation, Hawking radiation. For a large black hole, this radiation is incredibly cold and faint. The temperature of a black hole is inversely proportional to its mass. A black hole with the mass of our sun would have a temperature of about 60 nanokelvins, colder than the current cosmic microwave background. Its Hawking radiation would be utterly drowned out. But as the universe expands and cools over the eons, the background temperature drops toward absolute zero. Eventually, perhaps around 10 to the power of 40 years into the future, the universe will become colder than even the largest supermassive black holes. At that point, the black holes will become the hottest objects in the universe, not in any absolute sense, but relative to their surroundings. They will begin to radiate more energy than they absorb from the cosmic background. They will start to lose mass. This is the beginning of the end of their reign. The process is achingly slow. A black hole with the mass of our sun would take about 10 to the power of 67 years to evaporate, a number so large it has no analog in human experience. For a supermassive black hole of 1 billion solar masses, the timescale balloons to about 10 to the power of 93 years. These are timescales that make the degenerate era seem like a brief morning. Yet, the process is relentless. As a black hole loses mass, its temperature increases. The smaller it gets, the hotter it gets, and the faster it evaporates. The final moments of a black hole's life are therefore not a slow fade, but a runaway explosion. In its last second, a stellar mass black hole would release energy equivalent to millions of hydrogen bombs in a burst of high-energy particles and radiation, a final, brilliant shout against the dying of the light. In the absolute darkness of the black hole era, these evaporation events will be the last fireworks of the cosmos. Isolated, unpredictable, and separated by eons of perfect blackness, a pinpoint of intense gamma rays and particles will suddenly flare into existence, burn for a few seconds or minutes with the brightness of a primordial supernova, and then vanish forever. Each flash is an obituary for a gravitational giant, a monument to an era of immense power now passing into memory. As you begin to absorb the scale of this era, let the soundscape deepen. That deep, curvaceous drone of space-time is not one sound, but many, a chorus of different frequencies, each representing a black hole of a different mass. The largest produce the deepest, almost subaudible hums. The smaller ones produce slightly higher, but still profoundly low tones. Together, they form a slow, dark, cosmic chord, the funeral dirge of an active universe. This chord will hold, unchanging, for durations beyond comprehension. But if you listen with the patience of the universe itself, you might notice that the highest notes in this chord are the first to very slowly fade away, as the smallest black holes evaporate first. The chord simplifies note by note, over epochs that are themselves longer than all of previous cosmic history. We stand at the beginning of this long, final simplification. The kings have assumed their thrones. Their rule is absolute, quiet, and destined to end not by conquest, but by a slow, quantum mechanical sigh. As the black hole era progresses, the universe becomes a study in monochrome majesty and deep time ecology. The black holes are not just isolated monuments. They are the last engines of causality, the final sources of events in a cosmos sliding toward absolute stillness. Their interactions, though rare beyond measure, write the last lines of the universe's dynamic history. In the profound emptiness, black holes will occasionally encounter one another. These meetings are not collisions in the traditional sense, but slow, gravitational dances that can last for eons, drawn together by their mutual gravity over scales that would now be considered local. Two black holes will begin to orbit. As they spiral inward, they radiate energy away in the form of gravitational waves, ripples in space-time itself. In earlier eras, such waves were detectable chirps. Now they are drawn out, deep-frequency groans that stretch across millennia for a single cycle. When they finally merge, the event is both colossal and dark. It creates a single, more massive black hole, releasing a final, powerful burst of gravitational waves that propagates through the cosmos. But there is no accompanying flash of light, no burst of radiation. It is a silent earthquake in the fabric of reality, felt only by the structure of space-time itself. This new, larger black hole will then have an even longer evaporation timeline ahead of it, resetting the clock on its demise. But mergers are not the only fate. In the vast gulf between black holes, another process unfolds with even greater slowness: gravitational sedimentation. Just as dust particles in a quiet room eventually settle, the largest and most massive black holes will, over timescales that defy language, slowly drift toward the gravitational center of whatever region they inhabit. They may form a loose, dark cluster, a black hole galaxy without stars, without light, without anything but the pure, curved geometry of their mutual imprisonment. Within such a cluster, the black holes will engage in complex gravitational interactions. Through a process called gravitational slingshots, smaller black holes can gain velocity and be ejected from the cluster, destined to wander the infinite void alone. The largest ones will sink to the center, possibly merging into a single, unimaginably massive entity, ultramassive black hole that could be the final gravitational ruler of its region of space. Yet, even this ruler is not immortal. It, too, emits Hawking radiation, and as the eons pile upon eons, the faint hiss of this radiation becomes the dominant narrative. The black hole era is thus a story of two opposing forces: gravity, which seeks to gather and merge, and quantum mechanics, via Hawking radiation, which seeks to dissolve and disperse. For an almost eternal duration, gravity is in control, but quantum mechanics holds the final card, and it plays with infinite patience. The evaporation process itself is a curious inversion of stellar life. A star shines by converting mass into energy through fusion. A black hole shines by converting its own mass, the warped space-time of its being, into radiation through quantum effects. It is a cosmic recycling of the most fundamental sort. Mass that once bent light into imprisonment now becomes the light itself, set free into a universe too empty to ever absorb it again. As smaller black holes vanish in their final bursts, they leave behind a universe that is even darker, even quieter. The deep chord of gravitational presence loses its higher notes. The remaining black holes are the giants, the ones with temperatures still infinitesimally close to absolute zero, their Hawking radiation a whisper lost in the cosmic static of an even cooler background. If one could view this era from outside, it would appear as a near-perfect blackness, punctuated very rarely by a sudden, brilliant pinprick of gamma rays, the death scream of a black hole, and even more rarely by a silent, space-time shaking tremor from a merger. The intervals between these events are so long that they are, for all practical purposes, infinite. The universe is not dead, but its heartbeat has slowed to one pulse per trillions of years. In this near stasis, a philosophical truth emerges. Black holes represent the ultimate victory of structure over chaos, of order over entropy, but only temporarily. They are pockets of extreme, organized curvature in a sea of maximum entropy. Yet, by their very existence and eventual evaporation, they are agents of that entropy's final triumph. They gather order, hold it for eons, and then, in a final burst, disperse it back into the featureless void as radiation. They are the universe's last effort to remember what structure felt like, before even that memory fades. As the soundscape of this era surrounds you, listen to the dark chord. Notice how it has simplified. The glittering hiss of the smallest black holes is gone. The mid-range tones are fewer. What remains is a deeper, simpler, more profound set of bass notes. The hum of the supermassive and ultramassive black holes. Their sound is less a chord now, and more a series of isolated, deep pulses, like the heartbeat of a creature in hibernation, each beat separated by an eternity. This is the long Middle Age of the black hole era. The frantic diversity of the early universe is a myth. The slow decay of the degenerate era is a faded memory. Now there is only gravity's deep breath, held for epochs, and the faint, inevitable whisper of its eventual release. The finale of the black hole era is not a single event, but a drawn-out crescendo of silence punctuated by the last, defiant acts of illumination in the cosmos. As we approach its end, we witness the evaporation of the largest black holes, the last structures that can be said to have an event in their lives. Their departure marks the true end of classical causality, of things happening to other things in the universe. Consider the fate of a supermassive black hole, once the heart of a galaxy like the Milky Way. For 10,931,093 years or more, it has sat in darkness, a sovereign of nothing. Its hawking radiation has been a negligible trickle, but as the universe's temperature drops ever closer to absolute zero, the black hole's own minuscule temperature becomes significant. It begins to lose mass at an ever so slightly perceptible rate. The process accelerates with terrifying slowness. For almost the entirety of its life, the black hole's evaporation is like a glacier sublimating in a vacuum. But in its final moments, a span of years that is still cosmically instantaneous, the process runs away. The black hole's temperature soars. What was a trickle of low-energy photons becomes a torrent of increasingly high-energy particles. Photons, electrons, positrons, neutrinos, and eventually, as the temperature reaches unimaginable scales, perhaps even heavier particles. The last second of supermassive black hole's existence is a cataclysm. It releases energy equivalent to billions of supernovae in a focused, violent burst of gamma rays and elementary particles. In the absolute blackness of the late universe, this flash would be the single brightest event since the era of stars. It would be a final shout across the void, a declaration of existence that has no audience, a monument to itself written in pure, fleeting energy. And then it is gone. The singularity vanishes. The event horizon dissolves. The intense space-time curvature smooths out. All that remains is a cloud of radiation, expanding and cooling into the infinite void. The last vestige of a galactic empire is now nothing more than a faint, dispersing mist of photons, one by one, across epochs that are themselves longer than the previous history of the universe. Each remaining black hole follows this path. The deep, pulsing chord of gravitational presence fades, note by deepest note. Each vanishing is marked by a brilliant, solitary flare, a last will and testament written in gamma rays. The intervals between these flares are so vast that each one might be considered the last event in its region of space for all of future eternity. With the evaporation of the last black hole, perhaps an ultramassive one formed from many mergers, the black hole era concludes. What remains? The universe is now devoid of all traditional matter. There are no atoms, no protons, no electrons. There are no stars, no planets, no dust. There are no black holes. The only entities that might exist are the decay products, the photons, neutrinos, and other fundamental particles emitted by the final evaporations, all redshifting to lower and lower energies as the universe expands. The universe has entered a new phase, one defined not by objects, but by free-streaming particles in an ever-cooling, ever-expanding emptiness. It is a phase of near-perfect simplicity. The complex structures born from the Big Bang, the galaxies, stars, planets, and life, have all been erased, not by violence, but by the relentless logic of thermodynamics and quantum mechanics over infinite time. This transition carries a profound emotional weight. The black holes were the last things that could be acted upon, the last things that could change in a meaningful way. Their evaporation is the universe's last performance. After this, the stage is empty and the play is over. There will be no more events, only the endless, unchanging aftermath. As you contemplate this final act, let the soundscape transform. The deep, pulsing hum of the last black holes begins to waver, rising in pitch and intensity as they heat up in their final moments. This rise is not swift in our perception. It is a slow, majestic swell over centuries or millennia. Then a brilliant, complex, and piercing tone erupts, the sound of a black hole's final burst. It is rich with harmonics, a chaotic, beautiful chord of dissolution. It holds for a few seconds of cosmic time, which to our stretched perception feels like an hour, and then it cuts off abruptly into a pure, high, fading whistle as the radiation disperses. This sequence repeats, each time fainter and further apart, as the last remaining black holes of various sizes meet their end. Finally, after one last, magnificent burst from the final black hole, there is no more pulsing hum, no more swells, no more brilliant tones. There is only the fading, high whistle of the last radiation, stretching and thinning as the universe expands, lowering in pitch and volume until it is indistinguishable from the background hiss of nothing. The black hole era is over. The last structures have dissolved into radiation. The universe is now an ocean of near-perfect emptiness. Its sole inhabitants are massless particles traveling forever through an expanding void. This is not an era of events, but of permanence. It is a universe that has shed all complexity, all differentiation, all history, and has become a pure, simple state of being. This is the dark nirvana. What remains? Primarily, photons, particles of light. But this light is nothing like the sunlight that warms our world. These photons are the funeral shroud of matter and structure. They are the Hawking radiation from the last black holes, now redshifted to incredibly low energies. They are the photons from the decay of the last protons, if protons decay. Stretched by expansion, they are the last vestiges of every star, every supernova, every creature's body heat, every thought's electrical impulse, all processed through the ultimate cosmic recycler, entropy, and diluted by expansion into a uniform, ultra-cold glow. Alongside the photons are neutrinos and possibly other weakly interacting particles, like gravitons. They too are cold, slow, and alone. All of these particles share one fate. They will never interact again. The universe has expanded to such a degree that the average distance between particles is astronomical in the truest sense, far greater than the current observable universe. A photon could travel for googol years and never come close to another particle. Each particle is on a solitary, eternal journey through an infinite, featureless space. Temperature in this era is a concept that has almost lost its meaning. The universe's temperature asymptotically approaches absolute zero, 0 Kelvin. But due to the expansion, it never quite reaches it. It might be 10 minus 30 Kelvin, or 10 minus 10010 minus 100 Kelvin. These numbers are not just small. They are symbols of a cosmos that has run out of energy gradients, out of differences, out of the ability to do anything. It is the ultimate heat death, not a sudden freeze, but the final, perfect equilibrium. In this state, time undergoes its final metamorphosis. With no events to mark its passage, time loses its arrow. There is no before and after because nothing changes from one moment to the next. The universe is static in all but name. The expansion continues, but it is so slow, and the particles are so far apart that from the perspective of any single photon, the universe might as well be frozen. The concept of a moment stretches to infinity. This is not the end of time, but its dissolution into eternity. Let us attempt a thought experiment, the last one possible. Follow a single photon from the final evaporation of the last black hole. It is born in a brilliant burst of gamma rays, but instantly, the expansion of the universe begins to stretch its wavelength. Within what we would call a few years, it is no longer a gamma ray, but an X-ray. Then, over millennia, it becomes ultraviolet, then visible light, then infrared, then a radio wave. As the eons pile up, its wavelength stretches to the size of a galaxy, then to larger than the observable universe. Its energy approaches zero. It becomes a ghost of light, a ripple in the quantum field so faint it is indistinguishable from the vacuum itself. This photon's journey has no destination, no purpose, and no end. It will never be absorbed, because there is nothing left to absorb it. It is a pure, eternal traveler. Its existence is the universe's final statement. I was, and now I am this. A memory traveling through nothing forever. As you begin to immerse in this reality, let the soundscape guide you. That single, high, pure tone is the collective voice of all the photons, their individual frequencies blended by expansion into one perfect, thin note. It is not a sound of sadness, but of resolution. All conflicts have been resolved. All stories have been told. All questions have been answered by the simple, unarguable fact of equilibrium. There is a profound peace here, deeper than any silence we can conceive. It is the peace of a puzzle completed, of a song that has reached its final, sustained chord. The universe is not dead, it is complete. It has achieved the state toward which all thermodynamic systems trend, maximum entropy, where nothing happens because nothing can happen. It is the end of becoming, and the eternal reign of being. But even in this perfect stillness, the universe has not yet reached its absolute final state. Expansion continues, and in the depths of quantum field theory, there may be one last, whisper-quiet process ticking away on a timescale that makes the black hole era seem like an instant. This process will lead to the true and final end of everything, not with a bang, nor a whimper, but with the slow, statistical certainty of vacuum decay. But that is a story for our final chapter. For now, rest in the photon sea. Feel the endless, gentle stretching. There's no pain here, no loss, no desire. There's only the infinite, calm exhale of a cosmos that has finished its work. In the photon age, the universe achieves a form of existence that is both utterly simple and philosophically absolute. To understand it, we must abandon our intuition about space, time, and substance. Here, the very definitions of these concepts unravel. Space is no longer a container for objects. It is an infinite, stretching vacuum, so vast that the term infinite becomes a practical reality. The notion of here and there loses meaning when there is forever unreachable and indistinguishable from here. The photon sea is homogeneous and isotropic to a degree that makes the cosmic microwave background of our era seem lumpy and textured. The universe is smooth in the most final sense. Particles no longer behave as discrete entities, with wavelengths stretched larger than the observable universe of any era. Each photon is more accurately described as a cosmic-scale quantum wave function, a probability smear across all of existence. They are not things moving through space. They are standing waves in a field that is the entire cosmos. The dance of photons is not a dance of partners, but a solo, eternal vibration in an infinite ballroom. What does existence mean for such a wave? It means simply to be a solution to the equations of quantum field theory in an expanding space-time. Its life is a mathematical truth, unchanging and eternal. There is no birth, no death, only the permanent fact of its equation. In this context, the remaining neutrinos and other ultrarelativistic particles share the same fate. They, too, are frozen waves, their oscillations slowed by expansion to frequencies so low that a single cycle would take longer than the current age of the universe many times over. They are fossils of a dynamic past, now entombed in the amber of eternal space-time. This leads us to the most mind-bending implication, the end of information. In our current universe, information is encoded in the arrangement of particles, the spin of an electron, the sequence of DNA, the text in a book. In the photon age, there are no arrangements. Every photon is identical in its essential properties, spin, though its frequency is effectively zero. There's no way to encode a bit of information, because there's no way to create a difference between one state and another. The universe has become a blank page, not by being erased, but by having every possible point on the page converge to the same, uniform shade of gray. This means the history of the universe, every galaxy, every planet, every life form, every thought, is not just forgotten. It is physically irrecoverable. The information is not lost in a black hole. Those are gone. It is not scrambled. It has been diluted by expansion and thermalization to such a degree that it is indistinguishable from the quantum noise of the vacuum. The universe has no memory, not because the memory is damaged, but because the substrate for memory no longer exists. From a certain perspective, this is the ultimate privacy. Every secret, every triumph, every tragedy is forever safe, not hidden, but dissolved into the featureless background of reality. It is a universe that has absolved itself of its own past. Yet, within this perfect equilibrium, the laws of physics still hold, and those laws contain a tantalizing, terrifying possibility: vacuum decay. Our universe might exist in a false vacuum, a metastable state that is not the absolute lowest energy configuration possible. If so, then somewhere, at some point in the spacetime of the photon age, a quantum tunneling event could trigger a bubble of true vacuum to form. Inside this bubble, the laws of physics would be different. The constants of nature, the speed of light, the strength of gravity, could change. This bubble would expand at nearly the speed of light, rewriting the universe in its wake. For our photon C, this would be the ultimate and final event. The eternal, quiet vibration would be abruptly replaced by something else. Perhaps a new universe with new laws, or perhaps an instant collapse into nothingness. But the probability of such an event in any given region of space per unit time is unimaginably small. The expected time for it to happen could be 101,056,101,056 years or longer, a number so large it is essentially eternity for all practical purposes. So while vacuum decay is a theoretical conclusion to the photon age, it is an ending so statistically remote that the age itself is defined by its unending, uneventful stability. Thus, the photon age presents two possible destinies, both resting on timescales that defy comprehension. Eternal stability. The universe continues to expand and cool forever. The photons cease stretching into an ever thinner, ever colder uniformity, forever approaching, but never reaching absolute zero and perfect equilibrium. Quantum resurrection, a random fluctuation, given enough time, triggers a new cosmic story, erasing the photon age in a cosmic heartbeat. For now, in the heart of this age, there's only the first destiny, stability. The dance is slow, silent, and endless. It is the universe at rest, having completed its journey from fiery birth to icy silence. As the soundscape of this era envelopes you, that single pure tone begins to reveal its true nature. It is not a sound in the universe. It is the sound of the universe, its fundamental frequency, lowered to the limit of perception. It is the audible signature of space-time itself, ringing with the memory of all that was. It is a lullaby for existence. As we reach the conclusion of the photon age, we must confront the ultimate frontier, the boundary of meaning itself. We have journeyed beyond the end of events, beyond the end of structure, beyond the end of time as a flowing river. What remains is a universe that exists as a pure, abstract state, a permanent answer to the question of what is, with no further questions to ask. In this state, the distinction between existence and nothingness blurs. A universe uniformly filled with photons of infinitesimal energy, separated by distances so vast they are effectively infinite, is indistinguishable from empty space. The particles are so dilute that any volume, no matter how large, is almost certainly empty. The almost is a mathematical technicality. In practical terms, the universe is a void. It has become the cosmic equivalent of a perfect vacuum, but one that remembers, in the faintest quantum whisper, that it was once vibrant. This is the final, gentle paradox of heat-death. The universe does not vanish. It becomes so uniform that it ceases to be a universe in any meaningful sense. It becomes a featureless, timeless, spaceless background. It is the canvas upon which the masterpiece was painted, now cleaned and left blank, waiting for a painter who will never come. Where does this leave consciousness, or the memory of it? If, by some impossible magic, a mind were to exist in this era, its consciousness would be a single frozen thought, with no sensory input, no change, no memory formation. Consciousness would be a state, not a process, a point of awareness fixed on an eternal, unchanging present. It would be the ultimate meditation, a oneness with a universe that is itself one, uniform thing. Then, even that point of awareness would likely dissolve, as the neural correlates, or whatever substrate it used, succumb to proton decay, or quantum tunneling into iron. Consciousness, like everything else, would return to the photon sea. This brings us to the final lesson of the photon age, and perhaps of the entire cosmic story. Impermanence is the engine of meaning. The beauty of a star, the drama of life, the agony and ecstasy of consciousness, all derive their poignancy from their temporary nature. In a universe that lasts forever in a state of perfect equilibrium, there is no beauty, no drama, no meaning. Those concepts require contrast, change, and an ending. The heat-death of the universe is not a tragedy. It is the necessary conclusion that gives the preceding story its weight and value. The silence at the end of the symphony is what makes the music meaningful. Thus, the photon age is not an abyss to be feared. It is the ultimate peace. It is the universe having told its story, having played its song, and now resting in the eternal quiet that follows. All tension has been resolved. All conflicts have been settled. All desires have been extinguished, not through lack, but through ultimate fulfillment, the fulfillment of reaching final, unchanging equilibrium. As this chapter closes, we stand at the threshold of the final possible transition from this eternal equilibrium to whatever lies beyond, whether it be true vacuum decay, a quantum rebirth, or absolute mathematical nothingness. But for an eternity that is functionally infinite, the universe will dwell in this photon nirvana. It is a state of grace, cold and dark, but profoundly complete. Let the soundscape of this final state be your guide into the deepest rest. That single unified tone, the convergence of all light, now begins to soften in a new way. It does not fade in volume, but in definition. Its edges blur. It becomes less a sound and more a presence, a feeling of spaciousness and calm. It is the auditory equivalent of a perfectly diffused light, with no source and no destination. This sound presence holds for a time that is not a time, and then, with infinite slowness, it begins to simplify even further. It sheds the last vestiges of its harmonic complexity, becoming a pure sine wave, the simplest possible oscillation. Then, even that sine wave's amplitude begins to decrease, not to silence, but to the quantum, zero-point fluctuation of the field itself. It becomes indistinguishable from the silent hum of the vacuum, the faint, eternal sizzle of existence at its barest minimum. This is the true sound of the photon age, the sound of the universe at rest with itself. It is a lullaby not for sleep, but for the eternal waking dream of a cosmos that has come home. Welcome to the last word. We have traveled across the lifespan of reality, from the first light to the last photon. We have witnessed the farewell of stars, the patience of iron, the reign of black holes, and the eternal sea of diluted light. Now we arrive at the ultimate destination, heat death. This is not an event within time. It is the condition of time's end. It is the state of maximum entropy, where the universe has exhausted all its potential for change, story, and distinction. This final chapter is a meditation on that condition, and on what, if anything, lies in the boundless forever that follows. The term heat death is a metaphor from 19th century thermodynamics, but it captures a poetic truth. The universe does not freeze in the sense of turning to ice. It reaches a state of uniform, incredibly low temperature, where no heat can flow, because there is no temperature difference anywhere. It is a cosmic uniformity so complete that the concepts of here and there, now and then, lose all meaning. The universe becomes a static, infinite, featureless tableau. In this state, the arrow of time vanishes. Time's arrow exists because of entropy increase, the move from order to disorder. At maximum entropy, disorder is total and can increase no further. Therefore, there is no longer a privileged direction from past to future. The universe is timeless. It is not that time stops, rather, the physicist's equations describing the universe become symmetric. The future is identical to the past, because both are identical to the present. The universe is a single, unchanging fact. What does this mean for existence? All processes that define existence, nuclear fusion, chemical reactions, life, thought, even the slow decay of protons and the evaporation of black holes, have ceased. The universe is processless. It simply is. In a way, it has achieved a kind of perfection. It is free from want, free from change, free from decay. It is the ultimate Buddhist emptiness, the Stoics' apatheia, realized on a cosmic scale. Yet our human minds, forged in a universe of change, struggle with this concept. We perceive eternity as an endless duration, a line stretching forever. But in the heat-death, duration is meaningless. Eternity is not a very long time. It is the absence of time. It is a state of being, not a continuation. The universe is not waiting for something to happen. It is in the final, forever now. As we contemplate this, we must ask the final scientific question. Is this truly the end? Our knowledge is bounded by our current theories of physics, general relativity, quantum field theory, thermodynamics. These theories point unequivocally to the heat-death as the ultimate fate for a universe like ours, with the observed constants and dark energy. But physics also whispers of possibilities beyond the end. One such whisper is quantum fluctuation in a de Sitter space. Our universe, dominated by dark energy, is accelerating toward a state described by de Sitter geometry, an exponentially expanding empty space. Quantum field theory in such a space predicts that, given infinite time, random fluctuations can produce anything with a non-zero probability. Given enough time, and here, time is truly infinite, a random quantum fluctuation could spontaneously generate a new Big Bang, a new universe, or even a Boltzmann brain. A self-aware configuration of particles that pops into existence, complete with false memories of a past, only to dissolve back into the vacuum an instant later. But these are statistical fantasies on timescales so vast they make the black hole era seem like a snap of the fingers. For all practical purposes, and for any meaning of practical that could ever apply, the heat-death is the permanent, unchanging reality. Another whisper is the multiverse. Perhaps our universe is one bubble in a vast, eternal foam of universes, each with different laws. The heat-death would be the fate of our bubble, but the greater multiverse continues, with new bubbles constantly being born, some perhaps lasting forever, others dying in fire or ice. In this view, our story is a local tragedy, but part of an infinite, untouchable eternity of cosmic fertility. Yet for us, within this bubble, the story ends here. The heat-death is our horizon, our finale. It is the closing of our particular book. As you begin to settle into this final reality, let the soundscape reflect it. That perfect, spacious quiet is all there is. There's no tone, no hum, no rhythm. There's only the awareness of absence. It is a sound so pure it has transcended vibration. It is the auditory equivalent of a blank, white canvas stretching to infinity in all directions. In this quiet, there is no narrator, no journey, no listener. There is only the fact of the universe, resting in its own completed nature. In the absolute stillness of heat-death, we confront the ultimate philosophical frontier, the nature of nothingness and the value of finitude. This is no longer the domain of astrophysics, but of metaphysics and meaning. The universe has provided the setting. Now we must provide the reflection. Consider the concept of nothing. We often imagine it as an empty space, a void. But the heat-death is not a void in that sense. It contains a diffuse, uniform sea of ultra-low energy photons and particles. It is a plenum, not a vacuum. Yet this plenum is so uniform, so devoid of gradients or features, that it is functionally identical to nothing. It is a something that behaves exactly like a nothing. This reveals a profound truth. Nothingness might not be the absence of stuff, but the absence of difference, of relationship, of information. The heat-death is the state of zero information. In that, it is the truest form of nothing our physics can conceive. Now turn the gaze inward, to the observer. Why does this ending feel so peaceful and not terrifying? In our daily lives, we fear oblivion, the end of our story. But the heat-death is not an abrupt end. It is the gentle completion of every story, the resolution of every tension. It is the universe achieving closure. There is no loss here, because there is nothing left to lose. All that could be saved, the energy, the matter, the quantum information, has been preserved, albeit in the most dispersed and uniform state possible. The universe has not been destroyed. It has been fulfilled. This leads to a radical shift in perspective. Our transient, beautiful, painful, vibrant lives are not rendered meaningless by this eternal silence. They are given meaning by it. The heat-death is the frame around the painting, the silence after the symphony, the dark sky that makes the stars visible. Our existence, with all its love and struggle, is the precious, fleeting contrast to the eternal calm that awaits. The darkness does not negate the light, it defines it. This is the great cosmic irony. Eternal existence in the form of heat-death is indistinguishable from non-existence. Therefore, true existence can only be temporary. To be something, to happen, to matter. These require a beginning and an end. The universe, in its most vibrant phases, was truly alive because it was temporary. The heat-death is the universe's death, but in dying, it validates the incredible, singular life it lived. What then of legacy? In a universe where all information is eventually lost, does anything we do matter? The answer is both humbling and liberating. It matters now. It matters in the moment of its happening. The universe experiences itself through us and through every star and atom. In the brief window between the fire of the Big Bang and the ice of the Big Freeze, that experience is its own reward, its own meaning. The legacy is not in being remembered forever, but in having been part of the story at all. We are the universe's way of knowing beauty, feeling love, and asking questions. That is enough. Scientific speculation allows us to peer beyond this absolute end, not with data, but with imagination. The cyclic universe model suggests a possible rebirth, a new Big Bang triggered when the infinitely spread out matter of the previous universe somehow collapses or quantum tunnels into a new singularity. This is the Phoenix universe, dying in ice and reborn in fire. While intriguing, it remains speculative. Even if true, each cycle would still have its own heat-death, its own eternal silence before the next awakening. The silence remains the ultimate destination of each individual story. Alternatively, the holographic principle in modern cosmology suggests that all the information of our three-dimensional universe might be encoded on a two-dimensional boundary, a cosmic horizon. In the heat-death, even that boundary would become featureless and cold. The simulation would end, not with a crash, but with the program reaching its final, simplest line of code, 0. As you sit with these thoughts, let the soundscape hold you in that spacious quiet. It is not empty, it is full of completion. There is no desire for something else, because here, there is no else. The universe is at one with itself. This is the peace that passeth all understanding, realized on a cosmic scale. It is the end of seeking, because all has been found. It is the end of wanting, because all wants have been resolved into pure being. This quiet is the universe's final gift to the listener, a deep, resonant assurance that all is well. All chaos has found order. All strife has found rest. The story is complete, and in its completion, it is perfect. We have reached the final boundary of thought, the shore of the silent sea. Our journey began with the fading of the first stars and ends here, in the eternal now of maximum entropy. Before we take our leave, let us gather the meaning of this voyage, not as a conclusion, but as a meditation on the arc of existence. The story of the universe, as we have told it, is a story of transformation. Energy becomes matter. Matter coalesces into stars. Stars forge elements. Elements form planets. And on at least one planet, they ignited the spark of consciousness. That consciousness looks back and wonders how it all ends. We have followed that wonder to its logical, physical extreme. The dispersal of all structure, the evaporation of all boundaries, the cooling of all fires, and the settling into an equilibrium so deep it is a form of cosmic sleep. This sleep is not unconsciousness. It is pure potential at rest. It is the universe having explored every possible configuration, every story, every tragedy and triumph, and now resting in the knowledge that all possibilities have been expressed. In a paradoxical sense, the heat-death is the universe's most informed state. It contains the outcome of every quantum event, every gravitational dance, every thought, all averaged into a uniform, silent answer. For us, the listeners, this journey offers a profound emotional calibration. The anxieties of our daily lives, the deadlines, the conflicts, the insecurities are real, but they exist within a frame so vast it renders them both precious and small. They are part of the brilliant, chaotic dance that precedes the eternal calm. Knowing the ultimate silence awaits can imbue our transient struggles with a strange beauty and a gentle perspective. It can foster gratitude for the temporary miracle of being, for the privilege of experiencing anything at all before the universe returns to stillness. This is the final gift of cosmology, not prediction, but context. It places our human story within the grandest story possible. We are not just living on a rock orbiting a star. We are the universe itself, in a localized, temporary state of intense experience, destined to one day rejoin the silent whole from which we emerged. As this series ends, let go of the need for a dramatic finale. The most profound truths are often the quietest. The universe does not end with a bang or a whimper, but with the deepest possible peace. It achieves a resolution so complete that it transcends narrative itself. Now, as we prepare to leave this contemplative space, I invite you to carry this peace with you, not as a resignation, but as a foundation. The knowledge that all stories end in stillness can free you to live your story more fully, more courageously, and with more compassion, knowing that every moment of light, love, and even pain is a unique, irreplaceable spark against the dark. The journey is over. The traveler rests. The story is complete. Begin a final 10-minute fade. The spacious quiet that has held us begins, ever so subtly, to brighten, not with sound, but with a feeling of lightness. It is as if the quiet itself is dissolving, not into noise, but into a warm, gentle, embracing presence. This is not an external light or sound. It is an internal shift. The infinite cold of the heat death transforms, in your perception, into the infinite warmth of acceptance. The void becomes a womb. The end becomes a return. This feeling of warm, peaceful presence grows, filling the space where the quiet was. It holds you. It tells you, without words, that everything is as it should be, that the story was worth telling, that you were worth hearing it. And then, very slowly, this presence too begins to soften. It doesn't disappear, it integrates. It becomes part of you, part of the room, part of the quiet night. It settles into your breathing, into the rhythm of your heart. The boundary between the cosmic story and your own awareness blurs, and then vanishes. You are here. The universe is here. All is well. Good night.